Hi Algebra 2, this is Mrs. Cowles, and today we're going to take a look at Lesson 5.3, Translating Parabolas. Our objective today is to use vertex form of a quadratic to write equations and to graph quadratic functions. So far, we have been working with quadratic functions in standard form. Standard form is of the form f of x equals ax squared plus bx plus c, where a value does not equal 0. Today we're going to start to look at vertex form of a quadratic function, which is written as f of x equals a times x minus h squared plus k, where once again a does not equal 0. And it's called a vertex form because we're going to be able to identify our vertex. Our vertex is going to be hk, and we're going to be able to find that in the equation. We'll notice here that our vertex, our x coordinate, is the translation of the x value in our function. Notice in the equation it's minus h, but when I pull it out, it's a positive h. So when we're pulling out the x coordinate, it's always going to be opposite of what's written in the equation. So we're going to write h is opposite of equation. The k value, which will be our vertical shift, it affects the y coordinate, will be the same as what's in the equation. Now, you'll notice that in vertex form, we also have our a value. This a value is the same a value that occurs in standard form. So whether it's in vertex form or standard form, the a value will be the same or equivalent. If the a value is positive, we know when it's in standard form, the graph will open up, and that's going to be the same when it is in vertex form. If our a value is negative, the graph is going to open down. We'll be able to find the y-intercept when we are given our function in vertex form. We know that the y-intercept has an x-coordinate of 0. So if I want to find the y-intercept, all we have to do is plug 0 in for x. So we have to use our knowledge that the y-intercept has an x-coordinate of 0. So if we plug the 0 coordinate in for x, we're going to be able to find the output that'll give us the y-intercept. Now, our parent function is f of x equals ax squared. Now, we studied this in our previous units where we had ax squared plus c, and if we see here I have ax squared, that means my plus c is 0. We know that our vertex would be at 0, 0. So when I have my parent function f of x equals ax squared, the vertex will be at 0, 0. Now what happens is when we have this parent function, we're going to have shifts when we write it in vertex form. We'll still have our a value, but this h coordinate is going to shift our x coordinate left or right. And our horizontal shift will be found inside the parentheses next to x. So the number inside of the parentheses will be your horizontal shift. It'll shift the equation left or right. So we'll call that horizontal shift. And the number that is outside is going to be our vertical shift, our k value. So that's the number outside of the parentheses. Our vertical shift will shift it up or shift it down. So we'll label that our vertical shift. Now you notice, once again, our horizontal shift will be opposite of what we think. Since it's minus h, that means it's going to shift to the right. When it's a minus, it shifts to the right. If this was a positive h, it would shift to the left. Sometimes some of your math teachers may have said to you, x lies and y tells the truth. X is related to our horizontal shift. When it's in the equation, it's lying to us as to which direction we should go, because normally we think a minus should go to the left. But when it's related to our horizontal, if it's a minus h, we're going to shift it to the right. If it's a plus h, we would shift it to the left. The y values tell the truth. The vertical shift is true. So if it's a plus k, it's going to go up k. If it's a negative k, it would go down k. All right, so let's go ahead and let's take a look at this here. We have y equals negative 1/2 x minus 2 squared plus 3. If we take a look, it's a quadratic function because our highest degree is 2. And we notice that it is written in vertex form. So from our vertex form, we see we have a minus 2 and a plus 3. Our vertex will be positive 2, 3. So in order to graph it, go ahead and plot your vertex because we are going to be sketching. So we're going to plot the 2 and 3. And now we're going to identify our axis of symmetry. Now I recommend that you do this without a calculator because when we quiz on this in a few days, these will be questions you will have to do without a calculator. So you should do your homework and the practice now without a calculator. So our axis of symmetry is x equals our x coordinate, x equals 2. So we're going to go over and add that to our graph. We'll draw a vertical line, x equals 2. And I always think it's a good idea to put the equation next to it, x equals 2. And now another point that we can find is our y-intercept. Now remember, our y-intercept has an x-coordinate of 0, so we're going to plug a 0 in for x. So y is equal to negative 1/2, 0 minus 2 squared plus 3. So again, it's without a calculator. This is going to simplify to negative 1/2 times, that's a negative 2 squared plus 3. That's equal to negative 1/2. Negative 2 squared becomes a 4 plus 3. Negative 1/2 times 4, that's just 4 over negative 2, which is negative 2 plus 2. So my output is 0. So my y-intercept in this case is 0. So my ordered pair would be 0, 0. Now I have my y-intercept. I can go ahead and I can reflect that over to find another point on the other side. So that would put me at 4, 0. So that's graphing the corresponding point of the y-intercept. You plot it, and now you're going to sketch your curve. So we know our curve is going to open down like this. And it says, what is the parent function of this graph? So if we were to cover up our vertex, our vertical shift, and our horizontal shift, we would cover that up, and we would cover up the other minus 2. We're going to end up with y equals negative 1/2 x squared. And I'm actually going to write that with function notation. F of x equals negative 1/2 x squared. Okay, so let's take a look at example 2. For y equals 3 times x minus 4 squared minus 2, what are the vertex, the axis of symmetry, the maximum or minimum value, and the domain and the range? Okay, so we take a look at our quadratic function and we notice that it is written in vertex form. When it's in vertex form, we can easily pull out the vertex. Remember, the x value lies to us, so when I pull the vertex out, it's going to be 4. The y value tells the truth. It'll be 4 and negative 2. Now the axis of symmetry goes through the x coordinate, so it's the vertical line, x equals 4. Now, before we are even to think about graphing this, we would think that if our a value is positive, we know that the parabola is going to open up. So by looking at this, we know it's going to open up. It's going to have a minimum. And we know the minimum value will occur at our vertex, and it's equal to the y value of our vertex. So my vertex is at 4 and negative 2, so my minimum value will be negative 2. I'm actually going to do a quick sketch of this over here. Put 4 and negative 2. I'm just doing a quick sketch. I know my graph opens up because it's going to help me see for my domain and range. Okay, so domain. How far left and how far right does your graph going to go? Well, I look at my parabola here and I see it's going up and to the left forever. Because it's going up and to the left forever, the x-coordinate, the lower end of our x values, is going to be negative infinity. As it goes to the right, it goes up and to the right forever. So again, as I move to the right, my graph continues to the right forever, so the upper value of my x-coordinates will be positive infinity. So the domain is all real numbers, but we are now using the interval notation, and we will write from negative infinity to positive infinity. Those are how our x values will go for this function. We can plug in any number we want. But is that true for the range? The range is our y value. When we read the range, we start from the bottom and we go to the top. Now if I come up from the bottom, I see my lowest point on my graph is at the vertex, and the minimum value is at negative 2. It lines up, as you can see. So my range, my lowest value for my y's is negative 2, but we saw from the top that it goes up towards infinity forever, so my upper end will be infinity. Anytime we write infinities, we use parentheses. We'll use a bracket around -2 because it's a solid point that's part of our range. So we need to include that. But we cannot bound infinity, so that's why we use parentheses. Okay, so try example number 3. You can pause the video and see how you do, and then come back and check, or just continue on. So for y equals -0.5 times x minus 2 squared plus 1, what are the vertex, axis of symmetry, the maximum or minimum value, and the domain and range? So it's in vertex form. So we see that our vertex is going to be at 2 and +1 because the x lies to us. Our axis of symmetry goes to the x coordinate, so it's x equals 2. When I take a look at my graph, I know it's going to open down because my a value is negative, and my vertex would be at 2 and 1. So it's going to have a maximum at a height of 1. Now how about the domain? As I take a look, my graph goes down and to the left forever. It goes down and to the right forever. So from my left to right, my domain is from -infinity to +infinity. But my range, and this is where students will mess up. We always have to put the lower end of our range first. Students will mix this up and it will be wrong. So you want to make sure you start from the bottom up. We see that our graph is going down forever, so our lower end of our range is -infinity, but it only goes up to this point right here, which is a y value of 1, so our height is 1, and we put a bracket around that 1. So that should be a bracket. Okay, so again, you should be practicing these without a calculator. You didn't really need a calculator for that one, but there will be questions on the quiz where you cannot use a calculator. All right, let's take a look at example 4. Write the equation of the parabola shown. Use the vertex form to write the equation. Again, do this without a calculator. They're asking you to use vertex form. So in order to use vertex form, the 3 things that you're going to need is you're going to need the a value and you're going to need the vertex. So step 1 is to identify your vertex and plug it in for h and k. Well, as I go over to my graph and I look at that picture, my vertex is at 3, 4. Now I'm going to go ahead and plug that in for h and k into my equation. So we're going to have y equals a x minus 3, because our x coordinate's a +3, squared, plus a +4. Okay, so we almost have it written. All we need to do is find our a value. Well, how do we find an a value? We substitute another point in for x and y. So I go over to my graph and I find a point. Well, you see they already have one labeled for you. If they don't, you find where the graph crosses nicely at a corner and you would use one of those points. But since they have this one labeled for us, we'll go ahead and use these points. So we're going to plug in 5 and -4 for y. So let's plug that for x and y. So go ahead and plug that in. We're going to have -4 is equal to a times 5 minus 3 squared plus 4. And again, do this without a calculator. So we'll start to simplify this. 5 minus 3 becomes 2 to the 2nd power. -4 equals 2 squared is 4. So I'm going to write that as 4a plus 4. Now we're going to solve it. It's just a 2-step equation. I subtract 4 from both sides. -8 is equal to 4a. Divide both sides by 4, and we have a is equal to -2. Now that I have a is equal to -2, I can go back and take that a value, and we can plug it in for our function, and we will have the equation. Y equals -2, x minus 3 squared plus 4. A skill you will have to be able to do on your quiz without a calculator. Okay, so at this point, I would like you to pause the video, and I'd like you to write the equation of the parabola shown, and I'd like you to write it in vertex form. Okay, so pause the video and then check back to see how you did. So vertex form is y equals a times x minus h squared plus k. So write it in vertex form. All we need is our h and k, which is our vertex, and to find out our a value. So if we go over to our graph, we see that our vertex is at 0, 0. So we're going to take that and plug it into our equation. y equals a times x minus 0 squared plus 0. Now when our vertex is 0, 0, our equation can simplify down into a x squared, and then the plus 0 we do not need to show. All we have to do now is to figure out our a value as we pick another point, x and y, from our graph. Well, if we go over to our graph, we see that we have the point 2 and 1. So we're going to go ahead and plug 2, 1 into our function for x and y. So we're going to have 1 is equal to a times 2 squared. As we simplify that, we get 1 is equal to 4a. And when we solve, we have a is equal to 1/4. So our new equation is going to be y equals 1/4 x squared. Because remember, we were using this function right here where our vertex was 0, 0, and we were taking that a value and we were plugging it in. Now I want to talk a little bit about that a value. So our parent function is y equals 1/4 x squared, but we can even take that back to the most basic parent function, which is where our a value is equal to 1. So I'm going to write my parent function, when my a value is 1, will just be y equals x squared. And if we make a table for that, we know that our vertex is going to be at 0, 0. And if I plug in a 1, 1 squared will give me 1. And then we're going to have 2, which would, when I square that, will give me 4. I'm going to go ahead and I'm going to plot that up on the same axis, but plot it in red. So 0, 0 is still my vertex. The vertex didn't change, but we're going to plot 1 and 1, and then we're going to plot 2 and 4. We're going to plot its corresponding points over our axis of symmetry, and we're going to graph it. So the original parent function of all quadratics is when my vertex is 0, 0, is y equals x squared. Now, in this function, our a value is 1. We want to talk about how our a value affects our graph. Now we know when it's positive, it means our graph is going to open up. When it's negative, our graph is going to open down. But the a value can also be known as a vertical stretch or a vertical shrink. So my a value is a vertical stretch, or it's a vertical shrink. Now vertical means the vertical height, up and down height. So it's the a value is either going to stretch our height from our x-axis, increasing it, or it's going to decrease the height from our x-axis. It's going to shrink it. So we take a look here. Here's the original parent function, and we can see it in red. Now, when I look at my output, for example, at 2, 4 when I'm at red, when I look at the output when I'm at 2 with the other function, y equals 1/4 x squared, I see that my height is only at an output of 1. So it went from 2 to 4, 2 to 1. Here we have a vertical shrink in height. Our a value reflects that it's going to be a vertical shrink, because when our a value is less than 1, it's going to shrink our vertical height. So if we see our a value is less than 1, it's going to be a vertical shrink. If we were to plot a new equation, for example, y equals 2x squared, we would see that our graph would increase in height a lot faster, and we would have what we call a vertical stretch, because we're going to see that the vertical height is going to increase from our x-axis. So just wanted to talk about how the a value not only determines whether the graph is going to open up or down, it'll tell us if our graph is going to have a vertical shrink or vertical stretch from the x-axis. Okay, so let's take a look at the last equation here. It says, write f of x equals 2x squared plus 10x plus 7 in vertex form. This is a quiz question that you will have to do without a calculator. So that means you have to memorize what vertex form is. Do you know it yet? F of x is equal to a times x minus h squared plus k. So when I have it in standard form, I know my a value is 2, my b value is 10, and my c value is 7. So right away, one thing that will cross over from vertex to standard form is our a value. So just by looking at this, I know that my a value right here is going to be the a value in my vertex form. Okay, so we already know the beginning of our equation that we will be able to plug into 2 for x. But how do we go ahead and we find out the vertex? So, and I'll even label it here, a is equal to 2. So how do we find vertex if I'm given this in standard form? So what do you remember from previous lessons? We remember how to find the x-coordinate of the vertex. What's the formula? We know that x is equal to the opposite of b over 2a. Again, this is something you should have memorized by this point. So when we go ahead and plug in our values, the opposite of 10 all over 2 times 2 becomes negative 10 over 4, which is equal to negative 5 halves. And if you were not to use a calculator, that would be negative 2.5. Some of you could do that in your head. Okay, but let's practice without a calculator. We'll leave that as negative 5 halves. So now that we have the x-coordinate, how do we find the y-coordinate? We remember we're going to plug in the x-coordinate of the vertex to find the y-coordinate. So here we go. We're going to plug that in. So we're going to have f of negative 5 halves is equal to 2 times negative 5 over 2 squared plus 10 times negative 5 over 2 plus 7. So when we square a fraction, we apply it to both the numerator and denominator. This is going to become negative 5 squared is 25 over 4 plus, now when we multiply fractions, we put this over 1. That becomes negative 50 over 2 plus 7. If I work this out, this becomes 50 over 4. Half of negative 50 is minus 25 plus 7. So now we can start to put these together. If I have negative 25 plus 7, that's going to be like 25 minus 7 is 18, but we have more negatives. So this is going to be equal to, so I'm going to come over here, this is going to be equal to 50 over 4 minus 18. And I can reduce 50 over 4. That reduces down to 25 over 2 minus 18. We can go ahead and find a common denominator, put that over 1. So we'll find the common denominator of 2. That's 25 over 2 minus 36 over 2. And when we subtract 25 minus 36, that should be negative 11 over 2. So f of negative 5 over 2 is equal to negative 11 over 2. If you know how to do that in your head, that reduces down to negative 5.5. So our vertex is equal to negative 5 over 2, negative 11 over 2. Again, that is something you should be able to do. All these skills, I know they're fractions, but that takes you back to 6th and 7th grade math. You should be able to do fractions without a calculator. Now we already identified the a value. We saw up at the beginning that our a value is going to be equal to 2 because that was the a value in the original function. Now we can write our function in vertex form. F of x is equal to a, which is 2, times x minus h. Well, since this is a negative 5 over 2, we're going to write that as plus 5 over 2 squared, and then it's minus 11 over 2. Okay, so things that you need to summarize. You need to make sure you know all of your formulas from standard form. You need to know the format for vertex form. You need to know the formula for how to calculate the x-coordinate of your vertex. You need to remember how we can then find the y-coordinate by plugging it back in. You need to be able to go through and rewrite equations. You need to write equations. If I give you a graph, you should be able to do that without a calculator. All these types of problems will be on your test. All right, Algebra 2, have a great day.